And the question reads, two dice are thrown together once. Find the probability of obtaining A, an odd number on the first die and 6 on the second. B, a number greater than 4 on each dice. C, a total of 9 or 11. So guys, this was the question, is probability question. So stay tuned and watch as we go down with the solutions. First of all, we have to find the sample space or the possible outcomes when a die is thrown once. You know that a die has 6 faces and each face represents a certain number of points when choosing the Ludo die. So this involves 2 dice. So let's get each of them represented with letters. So let's say die A and die B. So we have die A. So the sample space of die A will be, let's say we have X, which represents sample space, or we can use U, also meaning the universal set of tossing a die once. So that will be, we have 1, 2, 3, 4, 5, and 6 in a set because it's a family of members. So we have die B, which will be also 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and 6. Okay, so now we have the sample space of each of the dice. So now, when a die is tossed once, the sample space is 6. That's the members here, and each of them have 6 members. But if a die is tossed twice or 2 dice tossed simultaneously, what will then be the sample space? So that will be placed in the table here, and after that we count and see how many do we have. But we have A and B. So what we do is that, just like we did in the modulus arithmetic, we place each of the sample spaces on the columns here. This column will pick each of the sample spaces. Let's say die A. So we have A here. So the members of A are, we have 1, 2, 3, 4, 5, and 6. And the members of B, which will also be here. So that means A and B are going to intersect at this point. So we have B here. Okay, so these columns contain the members of die A, and this row here contains the members of die B, and which are also 6 members. That's numbering from 1 to 6. So that will be 1, 2, 3, 4, 5, and 6. Okay, so what we now do is that we look and pair at a go. 2 dice are placed together and tossed simultaneously. There's a probability that in die A you get 1, and in die B you also get 1. So we have 1 and 1 here. Okay, and in die, there's also a probability that in die A you get 1, but in die B you get 2. So we have 1 and 2. With the same concept, in die A you may get 1, but in die 2 the results may be 3. So you have 1 and 3. And still with the same process throughout. So we continue until this particular row is exhausted. Then we come down and pick 2, which is on die A on this column here. So you pick 2 and then you have 2, 1 and in that order. So that will be okay. So that row is exhausted. Now we come to the 2 which is on the column representing A and this row representing the members of B. So now we look when you toss 2 dice simultaneously or together once, you may get 2. You get 2 on the first die, which is die A, and the second die you may not get 2, but you will get 1. Therefore, you have 2 and 1, and you may get 2 on the first die, but will not get 1 on the second die, and you will not get 3, you will not get 4, you will not get 5, you will not get 6, meaning the only option is 2. Therefore, you have 2 and 2. So guys, it is the same scenario as we did here. So you do that until this row is exhausted. You come to this column, we have 3, and you pair with each of the elements on the row up here until this particular row is also exhausted, and you come with the 4 in that order. So let's go. Here we are getting 2 and 3 matches. So we have 2 and 3. We have 2 and 4, which match. So we have 2, 4, 2 match and intersect with 5 and 2 and 6. So let's come down as well and pick 3 on the corner. Now, in die A, when you toss, you may get 3, but it doesn't mean that on the second die you get 3. You may obtain a number, and that number will be 1. So, on die A, you get 3, and then the second die you obtain 1. So we have 3, 1, and then you use commas to separate them. They are individual elements put together. So we use comma to separate them. And when we come here with the same concept and scenario, we have 3 and 2. We have 3 and 3. We have 3 and 4. We have 3 and 5. 3 and 6. We come here, we pick 4, and that will mean that 4 and 1 with the same concept. 4 and 2, 4 and 3, 4 and 4, 4 and 5, 4 and 6. When we come down, we are getting 5 on the first die and 1 on the second die. With the same concept, we go to and 5, 2, 5, 3, 5, 4, 5, 5, and 5, 6. And the last column on the row, we are getting 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6. Okay, so we are done with the table. Now, what we have here represents the sample space of each of the dies. This represents the sample space of each of the die. Now, the 2 die put together. When we bundle the 2 dies together, this becomes the sample space. So let's count how many pairs do we have in the table. And that will be, we have 1, 2, 3, 4, 5, 6, That's 6 on the row. Now let's count the column. We have 1, 2, 3, 4, 5, 6. We have 6 on the row and 6 on the column. So 6 multiplied by 6 will give us 36. And it means that when a die is tossed twice or 2 dice tossed simultaneously, the possible outcomes or the sample space is going to be 36. So therefore, we have the sample space. We can also use U, and when you use U, it means the universal set, which is also widely accepted. So we have U, which is equals 36. So now we are done with the table. Let's go with A, and A says that we should find the probability of obtaining an odd number on the first die and 6 on the second. An odd number on the first die and 6 on the second. So let's go through the table whether we can see in a pair which have a pair with that is odd number on the first and 6 on the second. So let's go A. So that will be the events. Okay, the event of pairing will be what? So the event of pairing, that will be E, and E is okay. So let's go through. That will be odd number on the first and 6 on the second. So those to the when you pick a pair, those numbers to the left represent the first die or die A, and those to the second or those to the right represent the second die or die B. So let's look. We're looking for odds and 6. So we have them, they are in pairs, so we put them in brackets. So that will be an odd and a 6. So let's see. Okay, we pick the first row. Let's go to. We have odds, but no 6. We have an odd here and a 6 here. What is an odd number on the first die and 6 on the second? So we have 1, 6 in brackets, and we're putting another comma because we are going to list a series of them. So let's move on, and that will be, we are exhausted with the first row. So on the second row, these are all even numbers on the first, so let's ignore it. And on the third row, that will be okay. That will be here as well. We have an odd number here and a 6 here. So that will be, we bring that pair, and that will be 3 and 6 and another comma. So on the third row, that will be all. On the first row, the fourth row, we have even numbers first, so we ignore it. And on the fourth, we have odd numbers, and let's go to, okay, so we have 5, 1, 5, 2, up to, we have 5, 6, which is an odd number and a 6. So we have 5 and 6. Okay, so on the last row, let's see, we have 6 and 1, but 6 is on the second die, not on the first. So here we are looking for 6 on the second die, not the first. So definitely we don't need it. So let's move. Okay, so 6 be throughout, and 6 being an even number, then definitely we ignore it. So we have this are the events that are likely to occur if we are obtaining an odd on the first and a 6 on the second. So now let's count down the probability of obtaining the probability of the event occurring is going to be number of elements on the event over number of elements on the sample space. And we learned that when you see something here, the n here, it means that number of, okay, that's sets. If you had watched a video on set and its properties, we said that when you see this, it means that number of, so this means number of elements in the event occurring and number of elements in the sample space. So that is going to give us, in the event of occurring, how many elements do we have? Let's count. We have 1, 2, and 3. So the event is going to be 3. And how many elements are in the sample space or possible outcome? We have 36 here. That's all the pairs here. So that would be 3 out of 30. 3 out of 36. This fraction can actually be simplified, and that will mean that 3 will go to itself, that's once, and 3 will go to 36, that's 12 times, and this whole fraction has been reduced or simplified to 1 out of 12 or 1 on 12. Okay, so the probability of obtaining an odd number and a 6 on the first gives us 1 on 12. So now let's move to B. And B is saying that we should find the probability of obtaining a number greater than 4 on each dice. We are looking for a number greater than 4 on each dice. So that is going to give us so that will be B. And let's list the events that are likely to occur if we are looking for numbers greater than 4 on each. Or so guys, if you enjoyed watching our channel, as well, please subscribe, like, and share so that others will also have the benefits of the channel. The channel name is as well, Chris. So we are done with the A aspect. We are moving to the B, and the B is saying that we should find the probability of obtaining a number greater than 4 on each of the dice. It means that the first die you obtain a result greater than 4, and the second two you obtain a result greater than 4. So let's look. What will be the events that are likely to occur? So that will be, we have B, the probability of, okay, so the event occurring is, let's look, results more than 4 on each of the dice. So let's check. On which dice can we obtain results more than 4 on both dice, or on each of the numbers in a pair? So that will be here. We have, so on the, from the first row to the third row, we have none, and then on the fourth row we have none. On the fifth row, let's go to, we have 5, which is results more than 4 on both dice, and We have this also more than 4 on both dice. And let's check. We have more than 4 on both, and we have more than 4 on both. So let's go. Which are those pairs that have the stars on them? So we have this, that's 5 and 5. Second, we have 5 and 6. We also have 6 and 5. And 6 and 6 as well. So that will be 6, 6. So we now close the set. So that will be, okay, so we have this. Now, the event of pairing is this. Let's look at the probability of obtaining this particular event of that is likely to occur. So that will be the probability of the event of occurring equals number of elements in the event on number of elements in the sample space. So this will go on to give us how many elements are in the event that is likely to occur. We have 1, 2, 3, and 4. So therefore, we have 4 on how many elements are in the sample space. We have these, which are 36, and we have it down here. So we have 36. Now, let's look at this. We are checking whether 4 here is actually a factor of 36 or not, or how many 4s can go to 36 without a remainder. That is 9. Sorry, yeah, that is 9. So we say 4 both itself 1, and 4 on 36 is 9. And this will give us 1 on 9. So this is the results that was expected of this particular question. And the last one is the probability of obtaining a total of 9 or 11. The probability of obtaining a total of 9 or 11. So guys, this particular question, there are 2 ways of working it. And that is, firstly, you can list all of these together in one set. And secondly, you can also list those that sum up to 9 in one set, those that sum up to 11 in one set, and you find the probability of obtaining this, and also find the probability of obtaining this, and now add them together. That is an alternative way of doing it, but the simplest way, because in exams time is a key factor. So we will opt to use the simplest one, that is boxing everything in a single set. So let's go on and find the probability of obtaining a sum of 9 or 11. And what is the event of obtaining 9 or 11? So that will be, let's go through and find those that the pairs that will sum and obtain 9, or we sum and obtain 11. So let's go through the first, second, and third row. The first and second row we are not getting, because the last year is 7 and the last year sum up to 8. And on the third row we have this, we have 3 and 6 in one pair, and they sum up to 9. So we have this, and that will be, so we will mark those ones with bar below. So that will be 3, 6. And on the fourth row, let's go to, okay, so we have 4 and 5, which sum up to 9. So we have 4, 5. And on that same row, we are getting 5 and 6, which sum up to 11. So we have 5 and 6. Remember, we are looking for a sum or total of 9 or 11. So that will be this, and we move to the next. On the 5th row, that will be all. On the 5th row, we have, okay, so we have got this here. On the 5th row, this sum up to 11. So let's move to the 6th row. We have this, which sum up to 9. So we have 6 and 3. And when we move further, we are getting, okay, this 6 and 5 in a pair, and they sum up to 11. So this will give us 6 and 5. So guys, okay, so let's move on. That will be probability of the event occurring. We have number of elements in the event all over number of elements in the sample space. So this is giving us how many events are in, how many members are in the event. That's 1, 2, 3, 4, 5, 6. So we have 6. And how many elements are in the sample space? We have a whole of this 36 of them, which is here. So we have 36. So now let's look whether 6 up here is a factor of 36 down here. And it means that can 6 go into 36 without any remainder? Yes. And how many times? That's 6 times. So we are going to have 6 will go to itself, that's once, and 6 will go into 36, that's 6 times. And this fraction has been reduced or simplified to 1/6. So that is that. Guys, congratulations and a big thumbs up to you if you sat for this exams and you had this correct. And I say, guys, if you enjoyed watching, once more, subscribe, like, and share our channel. The channel name is Azor Chris. Let others also benefit from this. Place your comments below as watching or after watching. If anything comes into your mind and you would like to ask any question or you have anything to say, place it down there on the comment box. They are very important to ask. Guys, we are coming again sometime with a lot of the questions solved on this particular exams, the 2021 general or core mathematics past paper. So, and more, we are coming again with lessons or tutorials on each topic on the core mathematics lessons. After the revision, we are going to pick one topic after the other and then we place them down here. So guys, until we meet again, stay blessed and bye.